Okay, welcome to our webcast. I am Lester Knutsen with Advanced Data Tools, and this is another one of our series of webcasts we've had over the years. This one is going to be focused on Informix security, particularly how do you encrypt column data, and we want to share with you some examples of what we have done with some of our clients to help them protect data and to encrypt it. I'm Lester Knutsen. I started working with Informix in 1983, way back when it was called Relational Database Systems. This was even before Informix SE, where it was basically a set of CI/SAM libraries. And I was a C programmer, and I thought this was the greatest thing. It made my job so much easier to program with the I'm going to put everybody on mute. I'm sorry, so we don't get any background noise there. Sorry about that. The WebEx meeting, I tried to set it up so everybody would be on mute when they joined, but sometimes WebEx changes the settings, and I guess that got changed this time. So I apologize for the background noise there. Anyway, before I go too much further into this, so I've got to give some credit to a couple of other people on my staff here. Mike Walker, who's on the call, did a lot of the work on the demo I'm going to show, and has done some work with some of our clients doing it. Also, Emily Durr, who's not on the call, but another one of our staff, did some of the original work, and Rob Partlow also did a lot of the original work. So we've got a good team that's done a lot of work on this, and I'm just sort of building on what they did and putting it together to show you. And I'm going to go through a couple of slides here at the beginning, and then I'll have a long demo where I'll show you an example of using some of these encryption techniques. And then I'll go back to slides, and we'll have a question and answer period at the end. So this is what we're going to do. I'll talk about Informix column encryption. We'll do a demo. And then we'll talk about users and roles and some other security things. So the requirement for encryption. One need is the need to protect personally identifiable information, PII. And there's a lot on the web on this. You can do a Google. The rules are different. Every company, every agency I've worked with has different rules. You need to find out what the rules are that affect your business. The basic information that pretty much has to be encrypted is credit card information, bank info, social security numbers, driver's license, sometimes passport numbers, key information that could be misused, and if it was misused, you might be liable for. The goal of this webcast is to talk about how you implement encrypting columns that might contain this information in Informix. Now, most of the time, though, the problem I've seen with most of my clients is they have a database. It has a column for a social security number or for tax ID. And they've got applications that use that. And they can't afford to rewrite all the applications and rewrite all the database. So the question always comes up, how do you implement this with minimal change to the application and to the users? And I want to suggest, I'm going to show you a suggested way of doing that, which I think has minimal change. In fact, it only needs to really change your application when you have to decrypt data to see unencrypted data. And we'll go through how we've implemented that with a couple of clients. But that's really the problem is you've got an application, you've got a database that's been around for 10, 15 years, and suddenly you have a requirement now. These certain columns need to be encrypted. First thing you need to do is very clearly define what columns, what's the scope of what has to be encrypted. And usually when you go through your database and look at it, it's not as bad as people often first think. It may only be 5 or 10 columns that need to be encrypted. And that then makes it a manageable problem to focus on. Now, Informix, if you go to their Knowledge Center and look for column level encryption, you'll come to this page. And it has a great deal of information that I want to show you how to use. Informix, built into the engine, provides column level encryption. Now, just one caveat here. Some of this cannot be exported, so some of it may only be available in the U.S. I don't know all the rules on what can and can't be exported, so you need to check with your local IBM vendor to see if this is available where you are located. If you're here in the U.S., this is all available and will work. There are 5 functions that are sort of the key to it. One is a set encryption password, which sets a key to be used for encrypting and decrypting data. Think of this as, and I don't know why they called it the password. It's really the key that opens and closes the column and encrypts it. Then there is a Encrypt AES and an Encrypt TDES. Those are 2 encryption algorithms that are available, and both of those will take a string and encrypt it using the 2 different algorithms. And then there is a decrypt character and a decrypt binary, which will do the reverse. They will take a string that has been encrypted with Encrypt AES or Decrypt TDES and unencrypt that, so that you can then see what the data is that was encrypted. Very important, and I'm going to say this right up. If you lose your key, you cannot. There is no hidden back door to unencrypt this stuff. And if you lose the key, you cannot unencrypt it. The data is lost. So the key management is really important. And actually, that's the encrypting stuff is easy, actually. It's the key management where I've found on the projects that we work on where we spend most of our time, is how do you safely guard the encryption keys so they can be used and available when you need to use them. Now, you can encrypt character, var characters, nvarchars, blobs, clobs. These are the fields that you can encrypt. You basically can't encrypt binary data. Think of it as character data is what you're encrypting. Now, you can encrypt a number if you store it in a character field. Now, when you start encryption, it runs a separate oninit that can be defined in your onconfig file on startup, or if it's not defined on startup, it's going to be called and started the first time you start up or use an encryption function. So you could have a server. You don't need to set this in your onconfig file. You call the decrypt function, and the oninit process to run the decrypt will start up. As a quick example, if I look at what I'm running the server right now, and I have one oninit process, number 11 here, that's called Encrypt. That's my encryption process. That's running because about an hour ago, I started the server up a day ago, but about an hour ago, I tried my scripts. It started that encryption process. I'm going to shut down the server. And you'll see that that encryption process will go away until I show you the encrypt process later on. It does automatically start. That's the point I'm trying to make. You don't have to put it in your on config. But because you can put it in your on config, let's go take a look. Well, there's no encryption process running right now. So we'll come back and look at this when we take a look at it. But because you can input it in your on config, you can start a number of oninits for encryption. So if you have a lot of encryption to do, more oninits doing that might help you. And you can do it with the on config number equal and put here the number that you want to start. Or you can manually start them from your command line with the on mode -T option and tell it to start something called encrypt. Now, Informix keeps the password, and every time I say password here, I mean the encryption key in memory in an encrypted format. So it can't be dissected while it's in memory. And it uses a couple of random generated things, and I'll show you some of the impacts of this later on. So there's not a way to dump shared memory and see what the encryption key is. If you get a AF dump, you're not going to see the encryption key. There really is no way to get that encryption key back if you lose it, and that's by design. That's the safest way to do it. And again, I emphasize that because that means it's up to you to manage and control those. And I have a couple of ideas on how to do that, and I'll share that with you later on. So let's take a look at the encryption function. There are two. One, AES is the Advanced Encryption Standard. TDES is the Triple Data Encryption Standard. Basically, TDES is slower but more secure. And I don't really see a reason to use anything else except TDES because you want your data as secure as possible. Now, those functions take a couple of arguments. The first argument that must be there is the data to be encrypted. And so you could pass it, call the function, pass it a string, and it will encrypt that string. If the password session is not set, then you have to, as the second argument, pass it a password. Now, that's really a bad idea because then you run the chance of randomly getting different passwords for different things. And, you know, if you want that, you could do it. You've just got a lot more passwords to manage. The third option you can pass is an encryption hint. And there is a function called getHint that will retrieve that hint. Personally, I've never used that. I don't really think, you know, you want to encrypt the data, you want to save it, you need to manage your keys. This is not a web application where people might want hints to get. So a very simple, whoops, excuse me, slides jumped ahead there. A very simple example is you first run the function, set encryption password, and I'm setting it to ABC. That's literal. And then I call the function to encrypt a field called Encrypt SSN, and I'm passing it a Social Security number. And that is going to return an encrypted string into my Decrypt SSN function. And it's good to go. And I'll show you what that looks like in just a minute. Now, one thing to be very aware about, and this is why you just can't say, I'm going to encrypt this column, is the encrypted column size is going to be larger. And it needs to be larger than the original data, because it's got to store the full encrypted size. If it's too small, the data is going to be truncated, and you cannot decrypt it. I can't emphasize that enough. So you've got to plan this out to make the column containing the encrypted data large enough to hold all the encrypted data, because if it's truncated, it cannot be decrypted. You just don't have the bytes there to decrypt it. Now, the way to figure out how big your column is to just do a select length and encrypt something with the password, and if you want to, the hint you're going to use from systables where table ID = 1. And this will tell you how many bytes or how big you need to make your column. And I tend to say always make it bigger, because you do not want your data to ever be truncated. So, and it will be different. If you have a 10-character string, the length, the size of that encrypted data is going to be different from an 11-character string. So you've got to very carefully look at your string sizes and make sure that the encrypted column is big enough to hold what the data will be. Now, before I jump into the demo, I just want to say something about managing your encrypted password. This is really the key, because if you lose this encryption key or the encryption password, you cannot encrypt your data. And there are two ways, I think, that you can do this. In fact, there are more than two, but there are two that we've used. One is to store the key in a table in the database that only the user Informix or only a designated user can read. And in the example I'm going to show you now, that's the way it's stored. So that stores the key, and I've actually done this with clients where we have the key encrypted by another key. Sort of adds a double level of security there. The second way is to create a CUDR that has the encryption key. So now it's stored in compiled code. Someplace you have the source code for that, so and you want to protect that source code because that will have your key. But then on your runtime production systems, all you have to do is add in a compiled CUDR. This will be an oninit that runs, and it can be as simple as about 6 lines of C code. We've got one example where we've got it down to that, or as complex as you want to make it. But that then keeps the encryption key in a UDR that's compiled, that if you code it right, you want it so no one can run strings on it and find out what the characters are. And there are ways to do that. Because you don't want someone just to be able to run strings, which is a Unix command to show you all the text in the compiled program, and see what your UDR is. There are sophisticated ways of hiding it. And that's probably the most secure way of hiding your encryption key. So let me give you a little bit of a demo and a feel for how this works. And for this demo, I'm going to use our favorite database, the stores database. And I'm going to show you the end goal of it. I'm going to create a new table. And I'm going to have a field there called Social Security and a field called Tax ID down here at the bottom. And I'm going to want to encrypt those. So let me get out of the forms and go to query language. And the first script I'm going to run is drop that table I've already created. And I'm going to create a new table called New Customer. And it's just going to do a simple load from the customer table. And I'm going to put some text in here for the Social Security and the tax ID. And then I'm going to add two fields to hold the encrypted data. So the data in these first two fields, SSN and 10, is going to be my old data, the unencrypted version. Then I'm going to add two fields to hold the encrypted version. Let me run that. It drops and runs, and I should be able to, let's just do a select on that, and you can see I have my data. I've got a Social Security. It's not encrypted. I've got a tax ID. It's not encrypted, and my encrypted keys are blank. Also, if we take a look at the scheduler, I haven't done anything with encryption yet. So there is no oninit running that has anything to do with encryption. Now, let's go through, and I'm going to run a simple script that's going to set a encryption password. And this encryption password, I'm reading from a table in the database that is protected. Only the user Informix can read that. And then it's going to encrypt the Social Security number and the tax ID for every record in the database, and put it in the new encrypted Social Security and the new encrypted tax ID. Now, a comment here on this. We've done this both ways. Some customers we've worked with, it's okay to add the new encrypted fields right at the end of their existing database. Other customers I've worked with, that's not a good idea. And we actually create what we call a shadow table, a separate table that has a one-to-one correlation between the old table that has just the encrypted keys in it. Both work. Both are as easy to implement. I actually think the idea of storing this data in a second shadow table is probably better, because even though you can do a select star here and you won't see anything, you'll know there's encrypted data here, and this makes managing it a lot easier. And you don't change the original table at all that way. Key thing, though, is you want to hide the old data. And so what I'm doing here is putting asterisks in front of the old Social Security number. And I'm also putting asterisks in front of the old 10 number. So let's run this. Updated it, and let's see what it looks like now when we select all our rows. So there's what the data looks like when it's encrypted. It's taken the Social Security number, put asterisks in front of it so you see the last 4 letters, and this is the encrypted string for that Social Security number. And it's done that with all the fields there. And this is the point where if I forgot my encryption key, there's no way I can unencrypt that data. If I go back to my ISQL and look at my form, and this is what's great about this, my old form works. We've done this where you don't have to change the front-end application because it still sees the old Social Security number and the old tax ID with asterisks. It doesn't see, the application doesn't see the new fields. So for getting a hold of the old data, it still just works. Now, I have another form here that actually shows you what the encrypted data looks like too. So you can build that in and see what that looks like. Now comes the fun part. So how do you deal with new data? And go back to my SQL scripts. What I've found the key here is to create a trigger on a table. So every time a row gets inserted, and you can do this for every time a row gets updated too, it calls a stored procedure that encrypts that data. And so all I'm going to do is create a trigger on the new customer that is going to call my stored procedure to encrypt the new customer data, and it's going to call my function truncate to 4, which basically hides the old data. Run it. I've got that created. And now let's go back to my form, and let's go run this form. And let's add myself. Hit escape, boom. But guess what? The number is still there on screen, and this is one point I want to make. The trigger in the back end has encrypted that data. But because that was done by the database, it's not yet changed on the screen. If I go over here to the current function, which means reread the current row, I now see the encrypted data. So the data in your application doesn't change until it rereads that row, which is usually okay. Somebody's entering, a Social Security number or something like that. They entered it. They know what it is. Until they reread that row or go on to the next row, they're going to still see what they entered on the screen. But once they go to the next row, they are not going to be able to see it because now it is encrypted. So let's take a look at that data. Let me run DB Access here and get that select. There's record number 29 is the one I just entered for Knutsen. And there's all my data, all nicely encrypted without me having to do anything. So the trigger takes care of that work for me. Let's go through and add another customer. Let's just do it again. I'm going to call it test 2, test 2. Come down here and enter some data. Again, let's flip over to this next screen. Let's restart our query. there you can see test 2, their data is in the database encrypted. And if I say, show me the current row, I've got the row hidden. If I exit out of here and run my other perform screen, which shows there, it shows all the data, the encrypted fields. I've got my encrypted fields there. So the great thing about the trigger is that will encrypt all data. So let's say I have a program or a batch program that adds new customers. Here's an example little batch program. I'm going to insert 3 new customers. And it's putting in the 10 and the Social Security. And one of them I put them in blank, and the other I put them in blank. And let's just run it. And it inserted 3 rows, even though it only shows you that it inserted the last row. So let's do a query, and let's say greater than 130. You'll see the new 3 rows I just added. Again, they're all encrypted. So now I've got the data encrypted. How do I unencrypt it? This is the one place where you do need to make application changes, is in order to see the data unencrypted. I have an example select routine here. You have to have a procedure, and what I usually like is to create a stored procedure that decrypts the data. That way, the stored procedure handles getting the password, the encryption password. You can also add in checks to say, is this user allowed to decrypt data? What I've found the best way to do it is actually create a role. And in the stored procedure, you can check to see that this user is in that role, and maybe even say only people in that role can run the stored procedure. Even though I've done it with other clients where they want a user to be able to run it, and if they're not allowed to see it, it just shows them blanks. You can code that in. By having a decrypt stored procedure here, you can customize the way it looks and code it in to suit your requirements. So I'm going to run it, and there it is. I've got the unencrypted SSN, the unencrypted 10, and I've got the encrypted values there just to show you what it looks like. One last little bullet, and this came from a question from one of our customers. What happens that we're trying to figure out, how can you break this? So let's say, what happens if you encrypt the same value over and over again? So I'm going to create a little table here called test encryption, and I'm going to put 8 values. First 4 values are just going to be A, B, C, D, E, F, G, H, I, J. And then the last 4 values are going to be 1, 2, 3, 4, 5, 6. And I'm going to do it 4 times, and I'm going to for each one of those values. I'm then going to encrypt the data. And just to show you what I'm doing here, because I think this is kind of interesting to see the way this works, I'm going to select all the data and decrypt it. And let's take a look and see what happens. So, A, B, C, D, E, F got encrypted in the first record that way, in the second record that way, in the third record that way. They're completely different. You can't just figure out from putting in the same data over and over again how encryption and decryption works. The engine randomly or wisely, depending on how you look at it, changes the encryption based on your key. You still need your key to see the data, because introduction here is the decrypted data, and it does match what the original is. But the string is going to be different. The encrypted string, and that's my point here, is going to be different for every row. And when I get over to the 1, 2, 3s, again, the encrypted string is different for every row in the database. So that's sort of an introduction to encryption. Let me show you a couple of things, and then we'll take a few questions. So here on the slides, and I'll have the slides available tomorrow on our website, is sort of the example code I did to add the new fields encrypted. Here's the batch encryption program, real simple. Here's the trigger I used. Now it's calling two stored procedures, which I created to do the actual encryption work. Here's just an example of one of those encryption stored procedures. All I'm doing is setting up a stored procedure. It gets in a value and gets the encryption password. This could be from a UDR, the CUDR. It could be from another table in the database. And depending on the table, and the reason I do this is we've had one procedure that, depending on the table or the field, could update multiple tables and fields. It encrypts it and then sets the old data to, well, if it begins with an asterisk, we know, that was the rule here, that the data's already been encrypted. We don't have to encrypt it again. And that's, you don't want to take a field that was encrypted and then encrypted a second time, especially when you've hidden that data with asterisks, because then you've lost your original field. That's why we do that little test here before we update the data. And then here's a sample stored procedure to hide the old data. Basically, you put asterisks in the first 4 or 5 characters of a field depending on your business requirements. Again, these rules are going to change depending on your company and your organization and what data requirements you have for how you should encrypt data. And then a very simple select statement to decrypt the data. And again, I'm calling a stored procedure which decrypts that field. And all it does is look up and use the Informix unencrypt function to decrypt that data. And here's that stored procedure. Usually you want to put a check to see if the user has permission. So you control this with permissions. You can do that here. You can also do it if you write a CUDR, do it in there so that they don't even get the encryption password back unless they get that. And that's my example. Like I said, the couple of key things. One is, where do you keep the key? You can keep it in the database. You can keep it compiled in a CUDR. They both work. If you keep it in the database, make sure only the user Informix or a designated user or role that can unencrypt the data can see it. And one reason for making the user Informix part of that is you do need to be aware that when you do upgrades, when you do batch changes, if you did a DB export, the data is going to go out encrypted. So if you want to give someone the data unencrypted, you have to be able to run unencrypt on that field. And just doing a DB export of that encrypted data taking it to another database and doing a DB import, you cannot unencrypt it with the same key. The key only works on that server in that instance. Let me see what else I have. So this is a summary of the example. First, you create columns to hold the encrypted data. You can do that in a separate shadow table or at the end of the current table. Second, you create a stored procedure to encrypt and hide the existing data. Then you create a trigger to encrypt and hide all data on insert. This means none of your insert applications need to change. That's all done in the background. If you want to update data, you can do the same thing with an update trigger. And then none of your insert and update applications need to change. And we've talked with several clients, anybody probably needs to be able to insert data. Well, anybody who can insert data probably needs to be able to run the encrypt function. So that's why security on the encrypt is not that important. It's who can decrypt it. So the idea is you want to make it easy for your same people without any code change to enter data. That data gets automatically encrypted by the trigger. And then the only change needs to be is who can decrypt the data. So my first rule is on the Encrypt SPL, you want to grant that to everyone. You want to then create a function to decrypt the data, and you want to grant that to only authorized users. So only application changes that need to be made are those where you really need to decrypt the data. We've done this in a lot of reports. Don't really need to see the decrypted data, so it works just fine. And in one case, is like 99% of the applications did not have to change. There are only 3 or 4 that had to change. And it was in a case dealing with credit cards, the only change had to be with an application that dealt with refunds, where you had to refund back to the same credit card, so the person doing the refund had to see the decrypted credit card number in order to give a refund back. Very small set of changes to an application that way. And that's really the key here. This, this seems like a daunting task. In both cases where we've done projects that have implemented this, it's ended up not being that big a task by deciding to encrypt everything with a trigger and then just selectively decrypt when you really need to. Now, the last part of this I want to point out, and several of my staff said, if you're going to talk about security, you ought to talk about roles. And I sort of said, well, I've been doing this before. I first wrote an article, and it's out on our website, which kind of surprised me that it's still out there, back in '95 on using roles. They were a new feature in 7.1 UD1. I don't know if anybody here remembers that. But basically, roles allow you to give privileges to a role rather than individuals. And it's really important. We have a client who has something like 200,000 users over the course of 10 years. And their sys-tab auth table is one of the biggest tables in the database. If they had done it to roles, all you have to do then is grant and revoke privileges to a role and then assign a user to a role. And you can actually automate roles with the sysdbopen function so that when someone opens a database, they are automatically granted a role. That's really the way to simplify and manage security. Some of you may remember this back in '93, the first product, Advanced Data Tools, built and sold was a product called DB Privilege. And that was actually before roles. It was my homegrown version of how to do roles, because it was a set of 4GL programs that managed users and security, and you would basically add groups, and you would assign a user to a group, and they would get all the privileges of that group. That's long since gone. I almost pulled out the code for that to go for this demo, but I decided not to do it. Roles, one of the reasons I didn't keep that product up is when Informix came out with roles, you didn't really need to do groups the way I had done groups. And this is really the way to manage your security. Is grant all privileges at a role rather than an individual level, and then add your users to roles and go from there. And it basically reduces the complexity of managing thousands of users and roles. Makes life a whole lot simpler. Yeah, the syntax is really simple. You create a role, grant a role to a user, and then you grant privileges to the role. And the grant privileges to the role is the same as granting, the same syntax as granting privileges to a user. The only difference is when a user logs in, you need to set the role for that user. So that user then takes on that role for that session. And that can be done in the sysdb open syntax part of the server. So, questions. And if I unmute everybody, it's going to get really noisy. So what I'm going to suggest, you have a chat window where you can type in a question. If you have questions, let's take a minute and type it in the chat window, and we'll see what we have, and I'll answer that. Everybody see the chat window on your screens? First question, how many customers are using CLE? And what, could you define CLE so we know we're all talking about the same acronym? Because I know about 3 or 4 things. If you mean column level encryption, I know, okay. Good, Mark. Yeah, we've implemented this with a couple of sites, and I've got a couple of others that are looking and working on it. So it is doable. One of the nice things about the code is a lot of the code, I think, was borrowed from DB2, so it's pretty good. I mean, I won't say good code. It's solid code. It's been around for a bit. It's not like something Informix put in overnight. And yes, I have used punch cards. And then the next question is, have I used DB2? And I'll give you an answer here. It's not really, but I've passed the DB2 test. Should be a little bit of a joke there for everybody. Cool. Good to hear from you again, Mark. Any other questions? Good question. And there are 2 good questions here. The first question is, any performance impact? Yes, there will be a performance impact with encryption. Oh, I forgot to show you this. Let me exit out of this screen. There is another oninit, and there it is, number 11, the encrypt oninit. So any oninit that runs is going to have a performance impact. In my testing and implementing this on a very large critical site, it really, you couldn't measure it. So it wasn't like things slowed down, which actually surprised me. So yes, there is an impact, but it's not something that's going to slow things down. Now, a second question, and I think this is key, is DB export, DB import will break the password connection. That's correct. Using net backup to test, refresh your dev and test environments, that will also break the encryption. The encryption is only good on the server that encrypted it. When you take it to another server, you cannot unencrypt the data. That's the way you sort of guarantee that the data is really secure. So if you need to bring the encrypted data over to your other servers, you have to unencrypt it first. Most of the time, though, when you take data from production to a test and development environment, you don't want the real credit cards there. So that is, I've found, not really critical. It is critical, though, that you be able to restore onto the same server and the data can be unencrypted. Let's see. Good question. What's the return value of a null encrypted column when decrypted? It should be null. Now, I actually prefer to check and say if a column is null, don't encrypt it. That's one of the checks I like to put in my stored procedure that does the encryption. Because if it's null, there's nothing there to encrypt. So I think that's really the better solution is to, before you encrypt something, see if it's null, and then if it's null, leave it alone instead of encrypting it. That was a good question, too. Thank you. Good question on ER, and I actually have not tested this with ER. HDR, both of our sites have HDR. ER, I really have not tested this with, and that's a really good question, how it will keep the encrypted data. And in March, we have an ER course coming up, and sometime between now and then, I definitely plan on testing that. And Frank, if you're interested, we have a course in March where we'll test that out with the ER. Other questions? Well, cool. This has been a fun webcast. Good to see a lot of folks I know on these webcasts. That's always a lot of fun. Just a heads up, I will have the slides up tomorrow on our website. I'm going to try and get a WebEx recording up on YouTube. It may not happen tomorrow, and it's partly because it usually takes about 2 days to get the WebEx recordings processed and loaded onto YouTube. And I happen to be leaving day after tomorrow on a long trip to South America. So the recording may not be up until mid-December when I get back. I apologize that in advance. But the slides will definitely be up tomorrow for everyone to look at. Someone asked about enterprise replication, and I want to mention our training schedule for next year. We are, as far as I can tell, the only company in the U.S. that has held public training classes. We also do private training classes for folks. We have 4 classes scheduled, and last year almost all our classes filled up. We keep them small because every student gets their own server to do the class on. And depending on what else we're doing, we have somewhere between 8 and 10 servers available, so we keep our classes small because of that. In January, I've got the class for new Informix database administrators. I taught that twice this last year, and guess what? I had more Oracle DBAs in that class than anybody else. It's been fun to teach Oracle DBAs about Informix. Then in March, we're going to do an enterprise replication course. This is a new course that I put together this year. We've already actually taught it once, and it's going to be a combination of HDR, enterprise replication. The bulk of it is enterprise replication, but we do go through how to set up HDR so that when your primary HDR fails, or we simulate it failing, your secondary picks up enterprise replication and everything keeps working. And we do some stuff on the flexible grid in that. Then in July, Art Cagle and I will be doing an advanced class. This is a performance tuning class. And in October, we'll again do the class for new database administrators. I tell you, that is so much fun to do that class for a bunch of new Oracle DBAs who are learning Informix. And, you know, you can take your classes online from your desk, or you can come to our training center in Virginia. Last class, I've had people in India, in South America, in Ireland, and all over the United States in these classes. And it's kind of fun to get people in different time zones and different areas in a class. And we guarantee we'll never, you know, everybody always seems to be worried because IBM would always cancel classes. We never cancel a class. And I have taught a class in the past where only one student was registered. So if one student's registered, we will do the class. The other thing I want to talk about is our next webcast. In January, we're going to start off with a slew of webcasts. One is going to be on the fastest Informix DBA contest. And I've got to apologize. We have a contest ready to go for this year. We got busy. And because we got busy, we just decided we couldn't do it this year. And we're planning to do it probably in early January, February time frame next year. It's going to be all SQL. You're going to get an SQL script, and your job is to optimize that script. We're also going to do some hands-on real-world, you know, the buzzword is the Internet of Things. And what you really got to do is, what does that mean for you and for Informix? And Tom Beatty and Mike Walker, two of our staff, have been playing with different devices and ARM chips and various things. And so both of them will be doing their webcast in the January, February time frame on connecting up to Informix and the Internet of Things. Really exciting stuff. See your you know, temperatures and thermostats and various gauges, all the kind of fun stuff you can do with that. And with that, I would like to thank you all for attending. And please, if you have any more questions, email them to me. Like I said, I will be out for the next 3 weeks, so I may be slow in responding, but I will try and get to you. And we look forward to seeing you at one of our future webcasts in January. Thank you all.